starting topic 10, and I just wanted to give you a quick introduction to matrices. Okay, a matrix in math uses rows and columns to represent data. So it's a way to organize data. And when we talk about the dimensions of the matrix, we always put the number of rows first. So this particular matrix has 2 rows. Rows go horizontally, so you would say that's a 2 by, and then we look at the number of columns. Okay, columns go vertically. Okay, so we have a matrix here that is 2 rows by 3 columns. So we say the dimensions are 2 by 3. Each one of these numbers inside the matrix is called an element, and we might designate this. So we're talking about matrix A, maybe the elements of matrix A. You see that little subscript of 2, 1? That first number is telling you what row to look at, and the second number is telling you what column to look at. It's always rows first and then column. So if I go to row 2 of this matrix, that would be this row, and I look at column 1, here's column 1, so row 2, column 1, that would be this value right there. You see that's a 2. So if I go to the same matrix, and I'm looking at row 1, but column 3, so here's row 1, column 3 would be out here, that's a 0. Okay, so that's how we define the elements in the matrix as well. So we got some different matrices here that you might be working with. If I'm asking you for the dimensions of each one, let me move this up so you can see the full. Okay, if I first am asking you for the dimensions, it says what are the dimensions of each matrix? Well, this has just 1 row, but when we think vertically, it has 3 columns. So that's a 1 by 3 matrix. Okay, this has 1, 2, 3. Remember, rows come first. So 1, 2, 3 has 3 rows, and it has 2 columns. That's a 3 by 2. And this one out here has 3 rows, and it also has 3 columns. So 3 by 3. When the dimensions, the rows and the columns are the same, we call it a square matrix. We're going to work a lot of 2 by 2 matrices in this unit. That's a square matrix. A 3 by 3 is a square matrix. Find the following elements. So they want to go to matrix A, and we want to look in the first row, first column. First row, first column would be a 1. We want to look at matrix B, and we want to look at, it says 32 is the subscript. So row 3, column 2. Row 3, column 2 would be an 8. And C, if I'm looking at row 2, but column 3, that would be a 2. Okay, so make sure you understand how to name the dimensions and how to find the different elements. Okay, so some of the different things that we're going to do with matrices. The first thing we're going to do is we can solve a matrix. When 2 matrices are set equal to each other, that means that the elements in the same positions have to equal each other. So this element is in the first row, first column. It has to equal the element in the first row, first column. You can see they're both a 12. So they equal each other. Okay, that means that the element in the first row, second column has to equal the element in the first row, second column. So that's going to be 0 is equal to y. So you've solved that for y. Okay, we can look at the second row, first column is going to equal second row, first column. So 2x is going to equal 14. I can solve that by dividing by 2, and I can say x equals 7. And then you can see second row, second column, those are already equal to each other. So as you put variables into your matrices, we can solve for those variables. Okay, another thing you'll be asked to do is called scalar multiplication. This value out here out front is called a scalar, and what that means to multiply, and we're just going to take that times each element inside the matrix. So in this case, 20 times 9 would be 180. 20 times 11 would be 220, and 20 times 18 would be 360. So we put those values in a matrix. With scalar multiplication, the dimensions of the matrix should be equal to the answer. So this has 3 rows by 1 column, and my answer over here was also 3 rows by 1 column. They should be the same with scalar multiplication. Okay, we've also got some addition and subtraction. Okay, when we add matrices together, so it's asking you for m plus n. So matrix M, we're going to take the element in the first row, first column, and we're going to add it to the first row, first column. So M plus N is going to equal negative 3 plus 6 would be a positive 3. 5 plus 5 would be 10. 2 plus negative 8 would be a negative 6. And 0 plus 2/10 would be 2/10. So you're just adding the elements that correspond to each other in the same positions. Now ask yourself, if I were to switch the order of that, so if I were to start with matrix N first and then add in matrix M, would it change the answer? And the answer is no, because the order that we add two numbers in isn't going to change. So these two answers are going to be exactly the same, which tells us that adding matrices is a commutative property. Order doesn't matter. Now when it comes to subtraction, if I start with M and I subtract N, same thing, I'm taking first row, first column, and I'm subtracting the first row, first column. Okay, so this answer, negative 3 minus 6 would be a negative 9. 5 minus 5 would be 0. 2 minus a negative 8 would be 10. And 0 minus 2/10 would be a negative 2/10. Okay, so subtraction is going to work the same way.